Movie storytelling is a visual storytelling, and it relies on the capturing light as pictures and showing those pictures in sequence. So today we're looking at how we can record a still image and some of the artistic decisions we can make to change that still image. And next time we will look at how we can use different decisions, how directors have used different decisions in their storytelling with selection of lenses, selection of apertures, depth of field to help enhance the telling of a story. So the first thing you have to decide is what for you is a correct exposure. What has let too much light in and spoiled the image, or not enough light in and not recorded the events correctly. Because a camera works very much like an eye in that we have a lens, a focus aperture ring called an iris in your eye that changes the size of the hole, changes the amount of light that goes into the eye, and once it's been focused, there's a light sensitive area at the back. Your eye is recording information all the time, but in the camera it's split into distinct little chunks of information. So as well as having a series of lenses and a aperture ring, an equivalent of the iris, and at the back of it either a digital sensor or a piece of film, in between them there is a shutter which opens and shuts like a curtain to divide the light into little chunks of a 60th of a second or a 24th of a second, or however much light you need to get the correct exposure. So it's all about recording pieces of light on a film. If you've ever looked at a camera lens, you'll see that there'll be a series of numbers such as f2, f2.8 to f22 perhaps, that relate to how big a hole is in the middle of the lens, because inside the lens there will be a series of little leaves which interlock together and slide round such that they change the shape or the size of the hole in the middle. It's worth bearing in mind that this hole relates to the area, not whereas the numbers relate to the reciprocal of the diameter, which means that a small aperture, a small hole, actually has a large number, and a large hole actually has a small number, and that they don't go 1, 2, 3, 4, 5, because the area of a circle is pi r squared, so it's not a simple series. F5.6, for example, is half the area of f4 and twice the area of f8. And it's the area that's important because it's the area of the hole that lets the amount of light through. Now, changing the aperture doesn't just affect the amount of light that goes through. And this is where the director has to make a careful decision. It also affects what's known as the depth of field. And the depth of field is how much of what you see in front of the camera is in focus. There will be an area which is in focus. There'll be an area in front of it where the lens will not have focused it, and an area behind the image that's in focus that again will be out of focus. You want your storytelling element to be in that area that's in focus most of the time. The This is sometimes referred to as the circle of confusion. How big an area you can tell with your eye as being in focus that makes no difference. So when we can change this depth of field by changing the aperture, such as a large aperture lens, small f number, remember, will have a very narrow depth of field. Here we've taken a photograph of a page of text. The line depth of field is in focus, just fractional. The next line up is just in that circle of confusion. You can just about tell it's in focus, you can read it. The line after that is definitely out of focus. If you take it now with a small aperture, there'd be a much larger depth of field and you'd be able to read the whole page. So that is just a quick look at how we can change, by changing the f number of our lens, we can change the amount of image that's in focus, and we can draw therefore the audience's eye to a particular item. Video cameras are so good these days that we could, if we wanted to, probably get away with having everything in focus. But perhaps, like the picture on the left, we want to take a picture of the person and we want the audience to watch the person, not what's in the background. So that's the decision we have to make. Remember also that if you're halving the whole to get more stuff in focus with a wider depth of field, you're half the area of the whole, you're going to have to double the shutter speed to get the same amount of light through. And you don't want to double the shutter speed or increase the shutter speed if you're photographing moving objects, because then you will see the blur of the object move. So it's a balancing act between the two, trying to get things to the right exposure. Here we can see a series of images of the same object taken with different apertures and at different shutter speeds, and you can see that there's a series in that diagonal, which I've highlighted in green, where those images are all similarly exposed, but they're being taken with increasingly small apertures as you move to the right, and as you move down they've been taken with increasingly long shutter speeds. They've all given the same result, they've all given the same, in that diagonal, all the same result, all the same correct exposures, but if you were photographing something that wasn't flat like that, you would have a series of depth of field effects going on as well. So, in summary, by changing the aperture ring, the size of the hole from, on this chart, f1.4 all the way down to f32, we can make more and more of the image in focus. It lets less light through, so you have to increase the amount of time the shutter is open from, in this case, a thousandth of a second down to half a second. But if you're photographing something in a half a second, you can start to get motion blur. There is a way of compensating for this on modern digital cameras, and that is to change the sensitivity of the light sensitive material at the back. And you might have ISO numbers being a measure of the sensitivity of the photographic material at the back of the camera. But increasing the ISO or the ASA number, if you were using old-fashioned film, has the effect of introducing graininess, which may or may not be desirable. A lot of film, if you look back at old films and actually watching them on your video player and stop them, you actually see the grain through the film. So sometimes, although with modern technology you might not have to use high ISO, sometimes people do, just to get that effect, just to make it appear old. It's another decision that the director's going to make in controlling the amount of light that they let through the camera in their storytelling. So I've got an image here just showing that. Here we've got an image, it's of the Golden Gate Bridge taken at different ISOs. And as you can see, the one on the left, the ISO 100, is a very slow film. It allows you to capture a very clean image. As you move across to the right, you're beginning to introduce graininess until you get, and when you're at ISO 3200, ISO 3200, you might decide that that's too grainy a picture to use. In which case, you have to make the ISO less, make the sensitive material less sensitive, and compensate for that by letting more light in with either a slower shutter or a larger aperture. It's a three-way process, balancing the noise, the depth of field, and how much motion you want to capture. Okay, so with that introduction, we're now on the next video go on and look at a couple of sequences from movies and try and decide what the storytelling element the director wanted and how they've used the camera and they've used the balance, the noise, the depth of field and the motion in their choice of camera lens and shutter speed and aperture to best tell that story element. Thank you.